that's like
it's like a flat line with a slope of 1/10. At 2, I would have, so at, that is 0.1. At 0, 2, I'm at 0.2, right? And so on. So you can see that these are going to slightly be, I'm going to exaggerate, but those are going to get taller or steeper and steeper as I go up. Okay? Let's go like 1, 1. What do I have? At 1, comma 1. It's going to be the same as that one, right? Everything across here is going to be the same. So these are all going to be like that. These are all going to be like that. And the same going up. These will always be flat because at 1, 0, I get 0. At 2, 0, I get 0, and so on. So those are all flat. So what I've created, or I am creating, is a slope field. It's a graphical representation of a differential equation. Now, I could go down, I think these will go be like this, and so on. If you have an original solution to the differential equation, it should be able to get drawn through the slope field. Okay, so what is the, if I plug in 0 for t, I get 4, right? So the y-intercept of that is 4. It's going to go 1, 2, 3, 4. You can see that it kind of shows the slope of the curve as it goes through it. Okay? So if you had a slope field that looks like this, that'll tell you the slope at any given point. It looks like the original would be a circle because it kind of fits the form, fits the tendencies of the slope field. Okay. So just to take a step back, slope fields, you'll have 1, maybe 2 questions, maybe 0 questions, between 0 and 2 questions on the AP exam on slope fields. Okay? I've seen where they ask you to actually create a slope field on the AP exam. It would be on a free response. They'll have all those dots on the graph drawn out for you, and you have to actually form and create the slope field. That doesn't happen very often, but sometimes it does. Most times it will have a differential equation like this, and you'll have, it's a matching. It'll say, find the differential equation that corresponds, or the graph that corresponds to the differential equation. That's more realistic. Okay, so let's see if we can graph that differential equation.
Good morning, your attention please. At this time, all 9th and 10th grade students should report to the PAC for the presentation on social media. Then, 11th and 12th grade report to the PAC for the presentation at the end of A lunch. Everyone please enter through the C hallway. At this time is 9th and 10th. At the end of A lunch is 11th and 12th.
Okay, wait, let me sum up the meeting. Cal, do you cyberbully people?
Yeah.
Good. Have you ever been cyberbullied?
No.
Good. That's all you need.
Yeah, I mean, why would you cyberbully people? You can't see the pain on their face.
Really? You want to do it in person?
I don't care what they say. Quartet
See
still
the
has
pain
words.
that they
At least it does.
Sorry, Anna. I'm talking to the side.
Yeah, I'm not.
Wilson, you can't see the
So if we're going to create this slope field, you pick ordered pairs. So let's start at 0, 0. So 0, 0, if I plug in 0 for x, 0 for y, we get
not
indeterminate. So when x is 0, you see the world blows up. So we can't really draw anything at x equals 0. So let's focus on like 1, 1. What do I get for a slope? 1 over 1 is 1, so that's has a slope of 1.
at 1, 2. When x is 1, y is 2.
2.
It's 2, so it's steeper than that one. At 2, 1, x is 2, y is 1, so that's 1/2. 3, 1, it's 1/3. It's getting flatter. 2, 2, it has a slope of 1. Same with -1, -1. 3, 2, plug in 3 for x, 2 for y, 2/3. I don't know, something like that. Do you understand how to create a slope field?
Yes.
Find the slope at that individual ordered pair and draw an arbitrarily short line segment at that point.
I still don't understand what you're using the slope field for.
Okay, so real life applications, the best situation I would say the slope field would be, have you ever seen a weather map where it shows all the wind vectors?
No.
Yeah.
Like you watch weather and it'll have all these little individual vectors, all like in Superior, Wisconsin, you've got a vector that's going. So it will show you the rate of change, in that case the wind, direction and magnitude on any points on the graph.
Where the slope would be, like, it's how fast it changes.
Right,
Okay.
yeah, so how fast the wind is moving, yeah. That'd
That's
be the
not
best.
really what I was asking. but
No, I mean, that's the
pretty
real
good
life
example.
thing. For mathematical purposes, it's just a graph of a differential equation on XY.
Okay.
Okay, so we'll do more of these. I think I actually have an activity, a worksheet that gives you,
Yes.
expands on slope fields. I'll prep you before the AP exam, what questions they would likely ask you about it.
What is?
Any questions specific to the slope field right now? Then we're gonna do one more problem
Are
together.
we starting 6-2 tomorrow?
Yep.
Will we be able to do all the homework with this knowledge then?
Well, most of the homework was review.
Well, yes.
This was the only thing that was new in the, so you should be able. Let's do one problem. Let's dive off a diving board or something. Or cliff diving. Let's go up on a cliff.
Good clip. I like it. What is that guy named Clip as well?
Can Dwayne
He's not suicidal.
No, that's
He's
a
just-
rock, Johnson.
He's having a fun time.
So Dwayne the Rock,
There's water below.
On top of a big rock.
No, there's not a rock fell.
not as much meat on his bones as he once had. But how high up is he?
He's Maui.
500 feet at least.
500
Say
feet?
about
500
12
centimeters.
inches.
He's Maui, so it's just 2
inches.
high.
That would be so terrifying.
All right, so